Bienvenidos, Ushamdi, and welcome to this HUT8 networking tutorial on MPLS Layer 3 VPNs. In this sixth part of a 7-part series, we're going to be taking a look at the PE to CE peering using EIGRP. In the previous video, we took a look at what would be required to set up the PE to CE peering using eBGP, which is extremely simple, no redistribution required. BGP, which is that multi-protocol iBGP peering we have in that service provider core, is going to take care of everything for us. However, when we use EIGRP, now redistribution is going to become part of the equation, and so we're going to have to deal with that. So let's go ahead and dive in on the command line here, and we will be talking about EIGRP. All right, so if I'm on the PE router, let's say that customer Z, and if I pull back our diagram here, you can see we've got our diagram here. A couple things have changed on the diagram. You'll notice we've got this truck. Well, I'm going to be saving that truck for the last video, and we're going to talk about what this truck represents here, the MPLS transport truck. And here's his cargo. So we've got customer Z in Coronado and customer Z in Laguna Beach. And they're going over the service provider core, and customer Z says, we want to use EIGRP to peer with you. And it could be for any number of reasons. It could be that their subject matter expertise is in EIGRP and that they don't have subject matter expertise in eBGP or BGP in general. So that's one reason. The other reason could be maybe they just want EIGRP for whatever the case may be. So let's go ahead and set that up, and we're going to start on the provider side. And this is where we've got one additional step. So if I go from user exec to privilege exec into global config, we're going to use the named mode of EIGRP. In fact, let's do this. On one side, on the router 3 provider edge 1 side, we're going to use name mode with the customer. And then on the other side, we're going to use classic old school autonomous system mode. So how do we do named mode? Well, we simply say router EIGRP, and then we're going to give it a name, and I'll just call it MPLS L3 VPN. Now it's here where I'm going to say address family IPv4 unicast. And you'll notice I could give an autonomous system number, or I could simply say VRF, right? Remember, we're working with VRFs here to support each of the customers on the provider edge side. So I'm going to say address family IPv4 unicast VRF customer Z. And then we still have to put an autonomous system number in here. So for customer Z, we'll do 65432 as our autonomous system number. And that's going to be everything. So now that we're into named configuration mode, what are the different things I could set? Well, I've got my network commands, and let's go ahead and set our EIGRP router ID. We want to make sure that we've got a unique router ID here, and so we'll keep it with the router number 0003. So we've taken care of that. Now I'm going to need a network statement for the interface on which I wish to run the EIGRP process. So 198.51.23.3. Again, that's the interface on the PE1 router. And so I'm going to lock it down to just that interface. Now, I'm intentionally going to leave a step out here for right now. We're going to come back to it, and you may know what it is as soon as I move over here to the customer router and say, okay, now let's go configure the customer side. And for the customer, it's super easy on the customer side, just like it is with eBGP and just like it's going to be with OSPF. Again, it's easy lifting for the customer. This is why MPLS L3 VPN is such a killer application, as the customer has very little to do in order to get this set up. So let's go ahead and run this router EIGRP. We're going to do name mode MPLS L3 VPN. I'm going to say address family IPv4 unicast VRF for customer, I'm sorry, I don't need the VRF for customer Z. Address family IPv4 unicast autonomous system, and we said 65432. So there we go. So no VRF needed on the customer side. All right, so now that I'm here, I'm going to do the same thing I did on the provider edge side. We're going to set the EIGRP router ID. I'm going to set it to 0002, keeping with the router number. And then I need my network statements. So let's go ahead. We're going to advertise the 2222 which is loopback 0 here on router 2. And now let's go ahead and kick it off on the interface 198.51.23.2, which is router 2 side. And I should see here, and there it is, right? You got to love when a plan comes together. I've got my EIGRP peering. So let me pop out here. Let me save my config just in case. And we're going to say show IP EIGRP neighbor. And you can see we've got a neighbor adjacency up right now with 198.51.23.3, and we know that that's the PE router. What if I say show IP route EIGRP? Am I going to see anything? And the answer is no, I'm not. But I have show run section router EIGRP. I have, in fact, advertised my loopback address. And let's make sure that that loopback address exists. Show IP interface brief, make sure we've got it configured, and we do. So let's go on to the provider edge router now. And on the provider edge router side, if I say do show, we'll say IP route VRF customer Z, and let's see what we see here in our routing table. In fact, I can even trim it down further and say, just give me the EIGRP information. So if you take a look here, we have the EIGRP information. It's showing up in the VRF routing table for customer Z. Now, what if I was to say do show BGP? Let's see. So remember, when we did eBGP, I could immediately say do show BGP VPN v4, VPN v4, unicast all, and say show me what we've got for the 2222, because I want to see all of that information. Now here we get network not in table right now. But this may be a little confusing. It's like, well, wait a second, I peered with the EIGRP. Where's the network? Why is it not showing up? Well, we'll come back to that in a second. We're going to knock it out on both sides at the same time. So now over in Laguna Beach, customer Z is doing the same thing. They're preparing and they're getting ready. And so let's go ahead and do the router 5 side, PE2. So we'll go from user exec to privilege exec into global config. And here we're going to do the old school autonomous system number. So we're going to say router EIGRP 65432, right? And that's pretty much it for old school autonomous system mode. Now, this is where it gets a little different, is now I am going to drop into the address family for IPv4 unicast. And if you take a look here, we're specifying a VRF for customer Z. Now, I still need the autonomous system number, right? 65432. And so let's watch and see what happens. You'll notice that even though I put 65432 for the provider, I can still put it down here for the VRF for customer Z. So now that I've got the VRF for customer Z sorted out here, I can do all the same things I did on the other side, right? So it's the old school EIGRP router ID, and we're going to do 000 and router 5. Whoops, 000 and router 5. And then I need a network statement for the 198.51, and this is going to be 57.5. And that is all I need on the provider side for now. Again, remember, we're going to come back here. So on customer Z, so the customer in Laguna Beach says, yep, we're going to get into privilege exec global config, and I'm going to say router EIGRP 65432. I'm going to say EIGRP router ID 0007. And then we're going to say network, and we're going to advertise our loopback address. So we've got some in LRI to look at there. And 198.51.57.7. And so as soon as I hit enter here, we should see in a couple seconds, and there it is. And the adjacency comes up. So if I were to say show IP route, I don't see any routing information from the other side. And let's come back to the PE router here. So again, if I say do show IP route VRF, customer Z, and EIGRP, I see the 7777, but I don't see anything from the other side. And so here's where and it's actually 2 additional steps technically, is we need to redistribute this information, right? Because remember, it's that multi-protocol IBGP peering. It's the VPN v4 prefixes that are communicated between those 2 PE routers, PE3 PE3 and PE5, that is how we're getting that reachability information from one side of the country to the other, or from Coronado to Laguna Beach, whatever the case may be. But we've got to get this information into BGP. And so here's where the additional step comes in. So on the PE router, I'm in EIGRP, so I can knock this out right now. But on the, and yeah, I can knock this out right now here with the redistribute command on the EIGRP side. So what do I want to do? Well, I want to redistribute BGP1, and we're going to put in the, whoops, sorry, not the metrics, but the metrics. So I'll just put in here, 200, 1, 1, 1, 200, right? And we can just put arbitrary values in there. So I'm basically redistributing BGP into EIGRP, and now I need to do the exact same thing. I need to redistribute the EIGRP into BGP. So we've got BGP into EIGRP. Now I need to redistribute from EIGRP into BGP. So let's go ahead and get into router BGP1. And I'm going to say address family IPv4. Now let's take a look at our BGP do show run section router BGP and see what we have here. And you can see we've got customer A's VRF, right? All of the customer A stuff is still up and running, and it's working great. So I'm going to need another address family for IPv4 in a VRF. So we're going to say address family IPv4 VRF customer Z. And here, do I need a neighbor statement like I do with customer A's VRF? And the answer is no. Remember, we're not peering with eBGP, right? All I'm here to do is to redistribute EIGRP 65432 into BGP. And so now I've successfully done that. So if I was to now come out on router 5 and say show BGP VPN v4 unicast all for 777732, now we do see information. But what about the 2222? Am I going to see the route from the other side? No, I don't see it yet. Why not? Yeah, because we haven't done the redistribution over on the other side, but we do see the information here. And there's a lot of information I like to call the crazy 88s. And the reason it's 88, and I've actually asked Donnie Savage, who's sort of the father of EIGRP, I've asked him this question at Cisco Live. The reason they used 88 was because that is the IP protocol number for EIGRP. And so these are BGP Extended Community Attributes, and we'll come back and talk about these in a second. But why do you think the origin is incomplete on the 7777? Yeah, exactly, because it's been redistributed into EIGRP, or I'm sorry, into BGP. So the origin is incomplete. And then we've got the metric. And again, I'll come back. We're going to talk about these BGP Extended Community Attributes for EIGRP information in just a second. But what we want to sort out now is the other side of the equation. So we're going to come over here to PE3, and we are in the, I want to say, the EIGRP config, but we'll just go ahead and we'll do it on the BGP side first. So I'll say router BGP, and actually, yeah, so we'll go router BGP1, address family IPv4, unicast VRF, customer Z, and remember, all I'm coming in here to do is to redistribute from EIGRP process 65432, or autonomous system 65432, into BGP. And now I need to go do the same thing on the router EIGRP, and we called it MPLS Layer 3 VPN, address family IPv4, unicast VRF, customer Z, autonomous system number 65432. Okay, so we're here. Now, can I just redistribute from here in the name mode? And the answer is no, you can't. The name mode kind of consolidated things. We need to go to the topology base, right? So here's where I'm going to be doing all of my redistribution. If I do a question mark, the redistribute command is going to show up right down here. So the old school mode, I could say router EIGRP 1000 and then immediately type in redistribute and do my redistribution. In named mode, you've got to get into the topology base. And so here's where we're going to redistribute the information. So we're going to redistribute into EIGRP BGP1. And again, I still need to put the metrics in here. So we'll put in here 200, 200, 256 or 255, and then 22 and 1, right? Again, they don't need to be exact. We can put arbitrary values in there. So I've done my redistribution on the EIGRP side over here. You'll notice the customer had to do nothing. Customer didn't have to redistribute anything, right? It's all on the provider edge side. So let's save our config just to be sure here. And now let's go ahead and say show BGP VPN v4 unicast all for the 7777/32. Now remember, we're on PE1, so this would indicate that we have successfully redistributed information if we see that right there, right? And so now we're redistributing from one routing protocol into another, a totally mutually exclusive routing protocol, right? So we're going from EIGRP, which has its own metrics, you know, the bandwidth and the delay. It's got its own composite metric calculation, and we're redistributing that information into BGP. And BGP has its own calculations for best route, right? And so how is it that we keep the EIGRP routing information transparent so that on both customer sides, it doesn't look, you know, it basically looks as if the provider core is sort of not even there, right? So that it's transparent to the customer users on either end. And it's all done with the BGP Extended Community Attributes. And here are those Extended Community Attributes. And while you probably don't have to have these memorized, you'll be able to pick out some information in here. And again, these are the individual Extended Community Attribute values. So 0x 8800, 8801, 8802, 8803, and then it jumps to 06. And I believe that these have changed a little bit. There used to be an 04 and an 05, which had to do with, I can't recall off the top of my head, but like right here, you can see that's probably the MTU, and coming out of 8803, the delay is probably in here somewhere. Bandwidth is probably in here somewhere. The autonomous system number, right? 65432. So there's our autonomous system number that gets communicated again, so that the service provider cloud makes it look transparent to the customer that the routing information is coming in as EIGRP information, right? Because remember, we're transporting EIGRP routes across the service provider cloud. So what does it look like over on the customer side? So here we are on router 2 customer Z, and this is the true test right here, is to say show IP route EIGRP. What are we going to see? Do we see the 7777? We do. And take a look at this, right? Same autonomous system number. So it's transparent. Even though we're redistributed into BGP and then redistributed from BGP back into EIGRP, it comes across as transparent. We are seeing this as an internal EIGRP route with an AD of 90. And then we've got a metric value here, right? So on the customer side, it looks like business as usual. Hey, I'm getting EIGRP routes, and that's all I need to know. And everything is good. So let's test our reachability, right? Let's go ahead and say ping 7777, and I'll source it from my loopback 0 address. And we've got reachability. What if I trace over there, 7777, and we'll source it from loopback 0. And we make it all the way over there. And interesting conversation, right? We're talking about MPLS Layer 3 VPNs. And take a look here. We see a transport label and we see a VPN label as we go across. So let's kind of do a walk across the topology. So the customer, we'll say router 2 customer Z on this side wants to send traffic over to 7777. So I say show IP route for the 7777. And I know that via EIGRP, and that is my next hop, and that is the PE router, right? And you can see we've got all kinds of information in here. So I see it as the PE router. And you'll notice that it says hops 2, even though if you look at the service provider cloud in our diagram, it would be 1, 2, 3, 4. But it's seeing it as 1 into the service provider cloud and then 2 out to the other customer edge router. Again, transparency being provided by that service provider core network. So let's come back here. So I do a show IP route on the 7777. So the ping packets or the trace route packets that I'm getting ready to send, they say, okay, well, we've got to get to 198.51.23.7. So let's walk over here to the PE1 router. So if I say show IP route 7777, what am I going to see here on the provider edge router? And again, I'm walking us into an issue. Yeah, the network's not in the table because remember, on the provider edge side, that command, that's for the global routing space. I need to say show IP route VRF customer Z for the 7777. And here's where we see, okay, so traffic from router 2, customer Z, shows up here at the PE router in the PE router's VRF, and there's going to be a routing table lookup here, and it's going to say, hey, okay, well, the next hop that I've got is for 5555. Well, we know that that's the multi-protocol IBGP peer. That's the PE router on the other side of our MPLS core. And so, excuse me. So take a look at what we see here, right? MPLS label is going to be 5006. So we're going to take a look at the labels in a second here, but I like this right here. MPLS flags. Yeah, MPLS is required to get me to the other side, right? So now I'm sitting here, we're looking in the VRF for customer Z on the PE router, and it says the MPLS label is going to be 5006. Well, let's say show MPLS forwarding table. What do we see for 5006? Do we see a 5006 here? We don't. So where is that label number coming from? Yeah, so remember when we did, and this is one of the nice things about sort of setting that label range value, especially in a learning environment, is we can look at that and say, well, okay, that label, that had to come from router 5, and it certainly did, the other PE router. So if we come to the other PE router over here, and I say, show MPLS forwarding table, right? Remember, when, and we'll bring this up a little bit here, remember, when Router 5 PE2 learned about this prefix, when the EIGRP adjacency was established with Router 7 for customer Z, I think I said customer 2, I meant customer Z. For customer Z, when the PE2 router learned about that, remember, it's going to assign it a label, and BGP takes care of this for us, right? So there's the label that got assigned, and that's what this V right there means. That's the VPN label. And so when we come back over here, and then that got communicated when we did all of our redistribution into BGP and from BGP back into EIGRP, this is when this gets communicated as multi-protocol IBGP for the VPN v4 address family, communicates that information across the provider cloud. And it comes over here to router 3. And so, router 3 PE1. And router 3 PE1 says, yeah, hey, so the next hop is 5555, but this is the VPN that this traffic is going to belong to, is when it gets to the other side to router 5, that is VPN membership. That's what that label is for. So now it raises the question, and I'm going to show you where we're going to see the transport label as opposed to the VPN label. So that's our VPN label. This is my next hop. So if I come into my forwarding table, all I have to do and look to see is say, okay, well, what label do I have for the 5555? Because MPLS is required. There's the 5555. My local label for that, right? The one I assigned on router 3, PE1, when I learned about the 5555 was 3003. However, if I'm going to 5555, I need to impose or push label 4001 onto the label stack. Because now we have a stack of labels. We've got 5006 and we've got 4001, right? So let's do another command here. So let's say show BGP VPN v4 And unicast all for the 777732 is what I think we want to see here. Yeah, and here it is right down here. So you can see MPLS labels in, out. So there's no in local label, but outbound, right? We have to put in this 5006. That's the VPN label, VPN membership label that's going to get placed onto the packet. Another command, show IPsec, is it VRF? Customer Z for the 777732. And show IPsec, oh, /23. /32. I was like, wait a second, we should see something here. And so this is another great way to check your label information, right? As to how this packet is going to make its way over to the PE2 router. And you can see here, the Ceph table knows that the next hop is router 4. Ceph knows that. It knows that's the outgoing interface. And it knows that that is the outgoing label that we saw right up here that needs to be pushed onto the stack. Now, that's our local label here. We're not pushing the local label on there. We're pushing 4001 on top of 5006. And when we did that traceroute command earlier, and let's just run it again here. When I did the traceroute, or actually, not from here. When I did it from PE1 or router 2 customer Z, when we did the trace, you can see there are the same labels that we just saw in the output we were looking at. And so that's kind of where, that's kind of where our truck is going to come into play, right? So the MPLS transport label, right? What is the transport label for MPLS? It was that 4001. The VPN membership label is 5006. And so here's what's going to happen. Picture is worth 1,000 words. And since I'm a terrible artist, here's how it works. If we were going from right to left, and I could do this for the, and actually let's do it for the 2222. That'll make more sense actually, because it's kind of directional there. So if we roll over here to PE2, if I were to say show, what are we doing here? Show BGP VPN v4 unicast all for the 222232, right? You can see that 3001 is going to be the VPN label because that's this VPN v4 family. So we know that's the VPN label that dictates VPN membership, right? So what about show MPLS forwarding table? We know the next hop is 3333, right? That IBGP, the multi-protocol IBGP peer on the other side. So my next hop for that is going to be outgoing label of 4000. So it's going to be 3001 and 4000. So I'll say 4000 is the transport label and 3001 is my membership label. And so let's take a look at PE1 router 3, and you can see, 3001, that is the VPN label that I communicated over to PE2, right? And you can see that's for the 2222 because it's in that VRF table. So we're good there. And what's going to happen is back to the drawing here. So traffic comes in from router 7 trying to get over to the 2222 customer Z over in Coronado, and he loads up. He's got the transport driver of 4000 because that's going to get him over here to router 4, and we've got our VPN label inside the truck, right, on the bottom. So then the truck, we wanted to get MPLS in there too. Hold on one second here. We've got some sound effects. So the truck comes driving over here, pulls into router 4. Router 4 is going to look and say, okay, there's a label, the MPLS packet just showed up, and the top label is 4000. So what is the P router going to do with that? Well, we just need to take a look at the label forwarding information base. So show MPLS forwarding. So, and again, we've got the incoming label here of 4000. So what do? Yeah, it's the penultimate hop pop, or the penultimate hop popping. So we're going to pop the label. And we know that we're going to go to 3333. We've got the interface and the next hop information here. But again, MPLS looks at that top label of 4000 and says, all right, pop that bad boy out of there. So we'll just put it there. And now we're going to go with one of the auto-driving cars, right? Because it knows where it needs to go, but it still has that VPN label. So he comes over here to router 3. Router 3 says, okay, we don't have a driver, but inside the truck, we've got this VPN label of 3001. So on router 3, whoops, where did router 3 go here? Sorry about that. Router 3 PE1, show MPLS forwarding table. I look into the truck, and what's the label we see inside the truck? We see 3001 inside the truck. So 3001, I look at my MPLS forwarding table and I say, hey, there's no outgoing label, right? Because I'm just going to take the label off. The VPN membership has been established. It's for customer Z. So I remove that VPN label and I forward the IP packet to the destination, which is out gig 02 to the next hop, who is customer Z. So we sort of did a packet walk right there with the truck as the example, and it works well, right? We've got the MPLS transport truck. Top label is going to be the transport label, who's going to be the driver until we have penultimate hop popping, and then it just kind of goes on autopilot. And then we open up the truck when it reaches its destination and look at that VPN label to see what VPN am I going to be a member of. And that is what that bottom VPN label is all about in the MPLS label stack. All right, well, that is going to do it for using EIGRP as the PE to CE routing protocol. And again, we took a look at the BGP Extended Community Attributes for EIGRP routing. And here are some of the commands that we ran that can give you some additional information. Again, I don't think I ran VPN v4 unicast all labels, but that's a great command to run. You can see your labeling information. And most importantly, we saw the truck, which kind of showed us, hey, here's how your traffic's going to go from one side of the provider cloud to the other side of the provider cloud. All right, guys, we have one video left. It's going to be OSPF is the PE to CE routing protocol. Thank you guys so much for watching, and thank you for putting me over 1 million views. On to the next video. Hope to see you there.